The last part of this set of slides has a really cool technique. It's almost like I thought nothing really could be invented. When I've seen this, it was 10 years ago, it was still like, what else can you do with color? We know a lot about color. There have been so many studies with color. And these guys from Japan, they came up with this idea of using two-tone coloring. So it really works well for data that is continuous. In other words, data that behaves a lot like this curve, and including this is 0 here, and this is a 0 here. So it works well for that kind of data. And what it does, it clearly shows the continuous part of the data. You'll see that some differences. So for the most part, here is kind of a large representation. If you don't have enough room to represent that whole graph over there, you can use color. You can just use one line with color, just like this. So the first one is discrete. So basically what it's saying, between 0 and 10, we're going to use black. Between 10 and 20, we're going to use red. Between 20 and 30 is going to be orange. And between the last part is going to be green. So that's what, no, it's kind of a full spectral scale that you can pick a different scale. It almost does not matter that much what color scheme you're using. It might matter if you try something, but I think for the most part it's not dependent on the color scheme. So you can see if I use this discrete, that curve would look something like this. Not entire, it's not very, it doesn't tell you much. If you don't see the plot on top, you don't understand a lot about it. The other thing is to use some sort of a continuous scale. So notice that 0 is completely black and 10 is completely red. And then somewhere here, 5 will be some sort of color that combines red and black. So it's a continuous change. So as I go through this scale this way, sorry, I cannot draw straight right now, the color keeps changing. No pixel is the same as the next one. No pixel as go from left to right. And then you end up with something like this. Again, not entirely, not giving you that shape of the curve. So what these guys thought of, what if we, instead of using a single color, what if we use two colors to code? So here is how this works. If you are at 10, it's going to be completely red. But if you go to 15, it's going to be half orange, half red. And it varies. So the top is going to be one color, the bottom is going to be another color. Now, this two-tone coloring, notice that I start to see the shape of that curve right there. So that's kind of their advantage. That's the interesting part. And like I said, it works pretty well with things that are continuous. It doesn't work that well. They were actually in their paper and presentation, they were looking at something that's binary, kind of 0, 1, 1, 0. And it wasn't that great for those. This is not continuous because it changes very sudden. It goes from 0 to 1 and then it comes back. But if it's continuous, it looks pretty good. And here is an example, Tokyo 2001 temperatures. So the top one is using the continuous coloring. Obviously in the summer it's hotter. And it's every day and every hour represented there. But if you look at two-tone, you start seeing temperature kind of in the middle of the day, it goes higher. You can see that at noon or towards in the afternoon, it's higher than in the evening. So you start seeing individual variation pretty neatly. Like look at this area here. There's 4 of them right there. So that's kind of the advantage of this. You start to see shapes like this. Somebody outside? Can you close that door, please? So that's the last part I had about color.